Really excited to talk about one of my favorite parts of the world, which is kind of on the border of the Southwest in terms of being in southern Colorado and northern New Mexico. So for those of you who don't have a sense of where this study was located, um, or super familiar with the Spring Creek fire, because I don't think it made anybody's news except Coloradans. It's in this area around kind of west of Raton, north of Taos. It's near the towns of, basically spanned in between Levita, Colorado, and Fort Garland, for those of you who are familiar with those little towns. But what some of the things that I found really interesting about this area, and the reason that I wanted to study it when these fires occurred, is this is really where the Southern Rockies meets the southwestern forests and ecosystems. And so it's really floristically diverse. Some of you who have spent time in these areas know that, both in the overstory and in the understory. And to give you some examples, this is kind of the southern extent of the of species like limber pine and lodgepole pine. It's also the northern extent of southwestern white pine, and this is kind of where the limber pine and southwestern white pine can can come together and create some hybrid species. So it's a really cool area species wise. There's bristlecone pine that burned in this fire, and kind of everything in between. And so the Spring Creek fire and this area in general spans from sagebrush, kind of lower elevation rangeland ecosystems, all the way up to alpine ecosystems, and all those forests and plethora of forests in between. So the Spring Creek fire burned in 2018. It was the third largest wildfire in Colorado's history, just burning a little bit over 100,000 acres. Don't hold it against it. We had a really big fire year in 2020, and now it's like the 6th or 7th largest wildfire in Colorado history, but at the time it was the third. And like I said, it burned over a really large elevational gradient and ecosystem gradient from those grassland ecosystems and rangeland ecosystems all the way to alpine ecosystems. Here's just another picture of that fire actually burning. And one of the things that got me interested in this is I watched this fire burn from my family's property. Of course, I really was excited about studying it from a research perspective until my family's property got put on evacuation notice. So we did not, our property didn't burn, but it did provide an interesting opportunity to check this area out and have more of an excuse to look at this beautiful part of the state. So to give you a better sense of this fire, it really burned kind of a range of burn severities. For those of you who may or may not be familiar with burn severity maps, the picture on the left shows a gradient of severities, the blue and green color being low to moderate severity, yellow being, blue and green being unburned to low severity, the yellow being moderate, and the red being high severity. And on this fire, about 40% burned at moderate severity, with only about 20–25% being high severity, and the rest being low to moderate. And we really worked with the State Forest Service to find areas and property owners that would be interested in us doing research there, potentially long term. Ultimately, my goal with this project is to continue to monitor these sites long term. So we reached out to a lot of ranch managers and landowners and HOAs to do this project. And so these study areas span a pretty wide range of this fire, as you can see in these red stars here. I also want to give you a visual of what this landscape looked like when we started doing this study. This is 1 year post-fire. All of that green area you can see in the front of the picture did burn. It's been a couple pretty wet years in general since this fire happened. Last year, this meadow had grass that was over 3 feet tall in most places. And this road is definitely not really a road much anymore, as much as a gully that has been created, or a nice water passageway. But you can see that that kind of low severity effects in the front of the picture and those high severity effects in the back, as well as a little bit of those different forest types. All those white trees in the background are aspen, whereas the trees closer in are ponderosa pines. So we have a little bit of a gradient there. Here's another picture of an area that burned at pretty moderate severity, but some of those trees definitely survived. This is a ponderosa pine and Doug fir stand. And then this is probably one of my favorite little spots within this fire because it's this great aspen grove that the fire burned all the way around it, but didn't really go into the interior of the aspen grove. So it's having really nice regeneration all around it, and the main part of the aspen grove didn't burn. So this fire has a lot of different land ownerships. It is not predominantly Forest Service land. There's some really large private land ownerships. And so as we began to have conversations with these different managers, we had a couple pretty big questions that came up for us in thinking about how people are managing their post-fire landscapes, like what's that decision space and why are they doing that? And how are these decisions affecting that post-fire ecological recovery? And that first part in regards to how and why people are making these decisions, I think it's important to note that this wasn't like a formal study that we did of these various landowners or managers, but rather, you know, what are the conversations that we're having with people and how are they making decisions across this landscape? And one of the things that we kept running into a lot in this area was logging and the desire to remove the dead trees. And this wasn't done for the most part in many of the areas that we studied for economic gain of those landowners, but rather oftentimes it was because of some desire, some sadness in losing those trees and losing that that ecological value that of these places that these people loved and wanting to, you know, make it not look so burned, I feel like, going forward. And that was what they could think of to do. So as well as wanting to make it seem like they're doing, you know, for some of these larger ranches, they wanted to seem like they were doing something productive, I think, on these landscapes and getting some value out of them, but not necessarily because of a huge loss in timber as their number one driver. So let's talk about what that ecological recovery looks like. And this is whether you do logging or not. The big thing that we were thinking about for this project was trees, right? What does it take for a tree to establish in a post-fire landscape? Really any landscape, but in this case, a post-fire landscape. And one of the big, like, number one kind of bottlenecks that we see in having having tree regeneration is that seed availability. And this can be often measured in post-fire landscapes as the distance to a nearest seed source, where when you're really far from a living tree, you're really unlikely to have an establishment of trees, right? If the seed doesn't actually get there, it's not going to turn into a forest again. But there's other kinds of bottlenecks that this might be at play here. Like, we know a lot of the ponderosa pine trees in the Southwest don't produce cones or a very large cone crop every year. And so perhaps even if they are close to an edge, we're not seeing that cone production and therefore the seed rain that we would need for new trees to establish. It was interesting on this fire, and in this area, there was a pretty large cone production in 2019. And so I don't think that was a limiting factor for this study. But we can talk more about that in a little bit. Some of the other factors that I think really influence, and we know from literature that really influences tree establishment, is soil moisture and soil temperature. And we often get at that in a number of different ways, by measuring canopy cover, by measuring surface fuels or surface cover as well, the number of trees in an area, the aspect and slope. And the reason that we do that, and we discovered that very well and vehemently in this project, is because soil moisture and soil temperature probes are kind of hard to keep track of and keep continuing to work in a somewhat remote landscape. And then soil disturbance obviously can have a really big impact. You can have the seed get there, it can have great soil moisture and soil temperature conditions, But if you suddenly have a big erosion event or you compact the soil a lot because of a logging operation, you might not be able to see that forest reestablished because those soil conditions are really not conducive to tree establishment. So this is kind of the roadmap that we went through to go from what's going on in these places, how are people changing them on their various land ownerships, to what is those ecological impacts that we might be seeing longer term. And I want to show you a couple pictures of what these landscapes look like over time. So this isn't a perfect picture comparison, but these houses, this cluster of houses here is the same as this roof that you can see over here. And this is one of the landowners that we worked with closely. You can see the meadow in the background is the same in both pictures. This is immediately post-fire, so before they did the logging. And this is what that landscape looked like after the logging. So you can see that, you know, unlike I think a lot of the current standard operating procedures on public land, they did do a clear cut, and on this particular property, they did largely remove the majority of the non-marketable timber and fuels on the ground as well. They really cleaned it up. And the way we set up our sites was trying to pair, because we had these conversations with with these landowners before, was pairing a low severity site with an area that had high severity fire and logging, with another area that had high severity fire without logging. In some cases, this was a little bit difficult because certain properties logged the majority of the area that could be logged, meaning that we could only get high severity on somewhat steeper slopes, but towards the edges of these clear-cut patches, we were able to get some plots. Here's another picture comparison of these of another property that we worked on, where you can really see, excuse me, what these areas looked like immediately post-fire versus post-logging. And all these logging operations took place by the fall after the fire. So the fire happened in 2018, and by fall of 2019, the majority of these properties that we studied were the logging was complete. All right, so our specific research questions were: how do forests differ amongst areas burned at low and high burn severity and those areas that experience post-fire logging? And how does the soil temperature and soil moisture differ, and what drives these differences? What are those forest structure measurements that we usually take that might influence the soil temperature and soil moisture? And then we also wanted to understand what are the drivers of these short-term post-fire recovery dynamics that we're seeing, specifically in regards to tree regeneration, like that first schematic talked about. You know, was that a conceptual diagram? Did that play out in reality? So to get into a few more weeds, with hopefully without overwhelming you with the number of different things we measured, we did look at a number of different forest types. And so we created blocks by forest type in these groups of high severity, low to moderate severity, and then high severity logged. In ponderosa pine, lodgepole, and a more mixed conifer that included ponderosa pine, Douglas fir, some small component of aspen, limber pine, and in a couple of places, bristlecone pine. We also, we strove to get low to moderate severity across all these forest types, but perhaps as some of you know, lodgepole does not like to burn at low severity. So we didn't end up getting, we paired high severity and high severity logged for lodgepole, but we didn't have any sites that burned at low severity for lodgepole pine. We measured basal area, stand density, canopy cover. We recorded the species and whether the trees were live and dead. We looked at surface fuels in a number of different ways, including percent canopy cover across, percent ground cover across these transects. We looked at woody fuels by size class. So this is basically talking about really small little twigs all the way up to big logs as 1,000-hour fuels. And we looked at species The seedlings by species, we didn't really need to age them because they were all 1 to 2 years 1 to 2 years old, as none of these areas had seedling survival pre-fire from that existed pre-fire. And then we did put in temperature and soil moisture probes. The soil moisture probes are a little bit more finicky and require a bigger set of equipment. And so we only had 9 of those, I believe, across these plots, whereas we did put soil temperature probes buried at least 3 of those per plot to kind of get an average of those conditions on that plot. All right, so to get into some results, the first is thinking about what's going on beneath the soil that might be really important for those establishing trees. And this is a whole bunch of tiny little dots. I understand that and might be a little bit confusing, but let me walk you through this. This is just the temperature or the days that we collected data for our temperature and soil moisture probes. And so it started in early to mid-May and went through the middle end of August. And the green line is low severity, red is high severity, and black is high severity logged. And so what we found is that maximum daily temperature was significantly lower throughout the entire summer in low severity burn sites, meaning that canopy cover, those additional trees on that area, are probably regulating that temperature a little bit and keeping it fairly more consistent than those fluctuations and those increases that we see in those high severity sites. It's not letting it get quite so hot. Between high severity and high severity logged sites, there was somewhat negligible differences, and actually a kind of different pattern than we expected emerged, where in early summer, those logged sites had significantly higher temperatures than just the high severity sites, whereas in later summer, the high severity sites had an increase in temperature, had significantly higher temperatures than the log sites. My interpretation of this generally is that, these are all kind of pretty harsh conditions, and it might depend, as you could see in those photos, that a lot of the black material in some cases in those log sites were removed. So some of that long-term heating potential is perhaps a little bit lower in those high severity areas because of the logging. Whereas conversely to that, those high severity areas do have a lot of standing dead trees compared to those logged areas that are just full sun exposure. And so that might be why early in the summer, at least, those trees are providing some shade and some moderating ability to those soil conditions. So minimum daily moisture, this is kind of the pattern we saw. And I just want to point out a couple really interesting things here, I think, where you can really see when the rain happens, right? For those of you who are in the Southwest, you're super familiar with the monsoons, and you can see it perfectly line out with the moisture that we saw in our soils. And it kind of runs out. And I think in those low severity sites, there's still a lot more vegetation cover, there's a canopy cover. And so it's not only has an increased capacity in those initial rain events to keep moisture there, but that kind of tails out and continues to be higher for much longer than the high severity sites, whether that's logged or not. We didn't find much significance in this, in part, again, because of that issue with our probes. I don't know how many of you have realized all the things that are attractive to wildlife, but one of the things that we discovered in this project is that many animals really love white cords on a black landscape, it turns out. And so we had to do a lot of maintenance. My graduate student, who's the lead author on this paper, did a ton of visits to these probes to try to fix them and splice wires back together to get these 9 probes to continue to stay out there and functioning. And we were marginally successful, but there are periods of time here where only 1 probe per site category was functioning, which is part of the reason that we had a hard time with statistics on some of this data. All right, so what influence does soil moisture, excuse me, and soil temperature conditions? Canopy cover was one of the bigger ones that influenced it. It wasn't, didn't explain a lot of the variability, but we did see that especially when there was much higher proportions of canopy cover, like these final points out here where we have 70–80% cover, we saw a lot lower maximum temperatures. If you're wondering what's going on here, you know, these are all our high severity log sites, which all have 0% canopy cover. And so these values kind of show the range of conditions across that elevational gradient, which in some ways corresponds to these values as well. But you do see a pattern where the higher percent canopy cover, and even if those are dead trees, in the case of high severity burn sites, is providing some moderating conditions for those maximum soil temperatures. We also saw that the percent of bare ground explains soil, excuse me, sorry, explains soil temperature as well, where the more bare ground you have, so the less vegetation, the less litter that's covering the ground, the increase in soil temperature we saw. And this y-axis here is minimum soil temperature, but this could, the pattern held true for maximum soil temperature as well, where you're just seeing consistently higher temperatures in those areas with the most bare ground cover, which makes sense, right? Things like litter and duff, as well as plants, can help moderate what those conditions are that are occurring within the soil. All right, so fuels. So this is thinking about all those surface fuels, again, from those tiny little sticks all the way up to those big logs. And in those tiny fuels, I guess really quick to back up, what we're seeing here is we did collect data in 2019 on a subset of these sites before they logged. And then once we had a better picture of where all the logging occurred, we increased our sample size. So that's what the dark gray is the 2019 values, to just kind of give you a comparison of what it looks like 1 year post-fire, which would be 2019, versus 2 years post-fire, which is 2020. But we only put in those soil moisture and temperature probes in 2020, which is why that's all that you saw in the previous graphs. But so in those smallest fuels, what we saw is that even the difference between 1 and 2 years post-fire, we saw a pretty big increase in those fuels in low severity sites, right? Which makes sense because some of those branches that may have died during the fire, even if the trees didn't die, are falling to the ground and starting to accumulate. Whereas at just those high severity sites, there really isn't a lot of fuel that has started to fall by 2 years post-fire. Conversely, in those log sites, because they removed all that fuel, even though in some of those projects, they did a pretty good job of removing all the additional fuels, there's some that's going to accumulate. And that was kind of consistent across the size classes of fuels. The other thing that I find interesting is that at these larger size classes, 100 and 1,000 hour fuels, we did see a significant increase in those logged site fuels. But while it's higher, it's not outside the normal range of conditions that we would expect in these ecosystems. And obviously you can expect these high severity sites to over time contribute a lot more fuel, right? They haven't started falling by 2020, but I can tell you after hiking around these sites in early summer this year, there was a big consistent wind event in May, and there is a lot more trees down that are contributing to much higher fuels in these areas now. Whereas these can't continue to accumulate fuels very easily, right? There's no standing trees. There's nothing that's there to contribute to continued fuel collection or contribution. All right, so let's talk about those baby trees, those tiny seedlings. What did we see? Well, 2 years post-fire, again, we wouldn't expect to see a ton. of many species. But one of the things that we did see was a really large number of lodgepole pine seedlings. Those trees are doing great. On these 9 out of the 10 sites that had these had lodgepole pre-fire, we had densities of 6,000, over 6,000 seedlings per hectare. So just imagine a field of tiny baby lodgepole pine seedlings, and that's pretty much what we had in all of those forest types. By comparison, pretty much all of the other trees are not recovering in very great numbers yet. Douglas fir had the second highest number of sites with seedlings that had those trees pre-fire, so a little bit less than half of them. But they were pretty low. You know, we saw 1 or 2 at a time, not very many. And that's similar with white fir and limber pine. We saw a couple out there on the landscape, but not very many. Ponderosa pine, we didn't see a single seedling, which I want to bring up because it was not due to the lack of a masting event. This was 2019 was a really good year, and I saw in this area, this larger area, a very high density of germinates of ponderosa pine in 2020, but we didn't really see any across the burn sites, which can be concerning if you're really wanting recovery of those lower elevation forests. And instead, what we saw was this really large abundance of growth of gamble oak. I know all of our favorite species. Hey, it's better than ceanothus. And here I want to point out that there is a little Douglas fir seedling hiding underneath it. So to say these areas are converting definitively to gamble oak, I can't speak to. But they are, but many areas, even those that didn't seem to have a very large presence of gamble oak pre-fire, we saw a really large recovery. And because it has been fairly good moisture years there the last few years, those gamble oak in many cases this year are 3, 4, 5 feet tall. Similar to aspen, so there seems to be a bit of a transition to these deciduous species where oak is taking over at those lower elevations, and then at some point there's a transition, and aspen is doing really well, even again across those sites where we didn't see it within the plot, maybe nearby, but not within our plot pre-fire. We saw a lot of aspen recovery that are also looking strong, except for elk browsing. All right, so what's driving that? Again, to try to match up these different measurements, we wanted to look at how soil temperature and soil moisture was impacting the tree establishment. And we did find that both temperature and soil moisture seem to have a strong effect on regeneration. And this was across whether it was low, high severity, logged. If you had lower maximum temperatures, you had higher seedling densities than those areas that were the hottest and driest conditions. So again, all of these sites here, this is our cluster of ponderosa pine forests that were the hottest and lowest elevation forests where we didn't see any tree regeneration. Similar with moisture, as soil moisture increases, we see an increase in the number of seedlings on these plots. Again, this represents a fewer number of plots because we only had 9 of those probes out there. But we did see a significant pattern that these, or a marginally significant pattern where these trees are with higher densities of seedlings when there is higher moisture, soil moisture. All right, so to kind of give some overview, hopefully I didn't throw too many graphs at you, and I'll show you a couple more fun pictures, but essentially we found that soil temperature and moisture were, we know that they're critical for plant establishment, and we are finding patterns that those variables are correlating with tree regeneration in these early post-fire periods. And this is whether they burned, regardless of what severity they burned at or whether they were logged. Those early post-fire regeneration was generally low across all sites, with the exception of lodgepole. And I will say that the fields of lodgepole did not seem to be impacted by those logging operations, in part probably because those logging operations occurred really shortly after the fire happened, but not too soon after the fire happened for those for that seed rain from those serotinous cones. Logging has definitely changed these landscapes, right? Those pictures do not lie. That's a different post-fire landscape than those unlogged areas. But we don't really, this study didn't assess what those long-term effects of forest recovery are. And while there may be some more longer-term effects, we didn't see strong drivers that logging itself resulted in lower early post-fire tree regeneration. And I think one of the biggest take homes with this is, when we're thinking about those soil moisture and soil temperature conditions, as we experience these large fires across our landscapes, we need to be really careful about what kind of planning we do, because if we're making those conditions harsher for trees to establish, increasing the soil temperature and decreasing the soil moisture, that could have negative long-term ecological effects. And so I think that's just something really important as we move forward to make sure we're quantifying and being really careful when we consider post-fire logging operations. And with that, I want to acknowledge, this project was largely done, and the first author on this paper is Jesse Wooten. And because I'm giving this presentation and not him, I have to show the embarrassing picture of him trying to dig out of a muddy, dig his truck out of a muddy, washed out road within the Spring Creek fire, that my Subaru got through just fine, I might add. I really want to thank the landowners within the Spring Creek fire who have allowed us to do this work and continue to allow us to visit these sites and others. The Colorado State Forest Service Levita Field Office was instrumental in doing this project, as they connected us to many people and told us the ins and outs of how to get around this area. We had a lot of really wonderful assistance from field technicians. And this project was funded by a number of different groups, so I want to make sure we acknowledge them. And the best field technician I would say that I had on this project was my son. My 4-year-old came out and helped me, helped us put in some probes. You can see him working hard while my actual technicians are just standing around observing. So I will say he was the hardest worker out there. Not really, but almost. And if you haven't spent much time in burned landscapes, always watch out for those morels. I never remember to bring enough containers for all those delicious mushrooms. And with that, I'll take any questions.
Great, thank you so much for that wonderful presentation. I really appreciate it. We'll go ahead and kick off with a question from Dylan, who asked, considering that Gamble Oak provides food and shelter and habitat for species like turkeys and bears, what do you see as the benefit of pine forest cover versus oak?
Yeah, that's a great question. I think there's a lot of benefits to Gamble Oak. I think, many people are opposed to it kind of dominating in these landscapes that were once, ponderosa pine or other conifer dominated species, but I think they both have a place on the landscape for sure. I think one of the concerning things I will say in this landscape is, again, kind of the prevalence in which it's taking over all of these different forest types. So this is actually a site that wasn't a part of this study, that was pinyon juniper that's coming back entirely as Gamble Oak. And again, we saw that all the way kind of through mixed conifer forests in terms of the elevational gradient of that takeover. So that was just kind of one of, I think there's benefits and downsides to it, but it's kind of the scale at which that conversion is happening that I think people may be less desirable for.
Yeah, heterogeneity makes everything work, right?
Yeah.
Alrighty. So I was wondering, do you have any recommendations for land managers, as well as some of the private landowners who are impacted, on how to balance the potential economic recovery from post-fire logging, the need to reduce heavy fuel loading to prevent future reburns, and your findings that salvage logging can negatively impact conifer regeneration?
Yeah, that's an interesting one. You know, I think I think that in part because of litigation, the Forest Service has set up some pretty good best practices for, you know, minimum number of trees left per hectare and size of trees that are left for wildlife habitat that could be relied on more heavily. I did have conversations with some of these landowners to try to get them to leave some trees, but that wasn't what they wanted to do. And I will say, you know, the economic piece is really interesting because certainly there were people who benefited economically from these logging operations. It was not the landowners. The landowners in many of these cases paid a timber company to remove the trees, and then the timber company also got the board feet cost or payments. So they got paid twice in some cases for the wood that got taken off of some of these properties. But there were others that milled it themselves or just sent it to a mill, and they probably got some economic recovery. But that definitely wasn't the driving force in these cases. I think that where that is more of a concern, there's certainly I think it has to be weighed at what kind of balance you want to strike of what's going to happen in the very near term, and potentially, like you mentioned, the reburn potential, which, you know, in the very near term, those logging operations could increase the potential for a quick reburn, but over the long term may not. With what you want that ecosystem to look like long term. So, you know, leaving some fuels to allow those microsite conditions or to have a nurse object for planting. You know, I know some of these properties have just signed contracts to plant like 40,000 seedlings in the next couple of years. So in that case, they're facilitating that recovery. So I don't know if that fully answers your question, but that was my rambly way.
Yeah, I think that gets to it, that it's a hard balance to strike. And you did touch on something that I also wanted to ask about, which was whether you think that some of these temperature increases and soil moisture decreases could be negated by the microsite plantings that you were talking about, you know, planting on the north side of nurse objects, or in sites which are logged but left with some standing, like you might see.
Yeah, absolutely. I think there's a lot of ways that you can minimize those changes. We kind of averaged across that plot with our multiple soil temperature probes. And so we didn't get at those really small scale differences that could occur when you were near a nurse object or something. So I think that there's a lot of validity. And Laura Marshall, who I know is on the call, is looking at that a little bit. And there is a lot, you know, higher potential for tree survival when you're near those objects. So that's certainly a possibility. But I will say, if you want that, you need to leave things on the landscape. So you don't want to just take all of the wood with you. You got to leave some, even if you're logging.
Great, thank you. Joe asked, his predominant species near Angel Fire, New Mexico, which I'm sure you're familiar with, is Engelmann spruce. So do you have any idea how that regeneration would come back post-fire, or just how species in general might impact what regenerates?
Yeah, so we didn't have a ton of Engelmann spruce on these sites. I guess there was a little bit, but we are looking at that in some of our 2020 fires in Colorado. And as well as I had a student a couple years ago who did some work in much older Engelmann spruce areas. And the thing about Engelmann spruce, I think, is that it's, you know, it's really shade tolerant and slow growing. And so it's usually one of the last species to come into a stand. So I would probably expect that you may have other species come in first, aspen, or if you have other pine species or something like that might come in earlier, and then those Engelmann spruce grow up underneath. Because I've also been in Engelmann spruce stands that had literally 100-year-old tree that was only this big. We cut it down and aged it, and it was 5 inches tall and 100 years old. So they certainly can be very slow growing, even in good conditions. So I would expect if it's burned to have some transition to a different forest type, but probably still the species around it might do well.
Well, and I think you noted in this presentation as well as in your paper that the site to seed trees, or the distance to seed trees, as well as what type of cones those trees have, if they're airborne or heavier cones, that's going to make a difference in regeneration as well.
Absolutely, yeah. And the seeds for Engelmann are fairly small, so they could disperse a decent distance, but they just don't really like those like hot, dry, really open landscapes. They like to be really shaded and protected for a while, I think.
Great, thank you. Xander asked, how do your findings fit into the existing literature on post-fire logging? Similar, dissimilar?
Yeah, I mean, I think in many ways it's similar. It doesn't paint logging as post-fire logging as super beautiful or ecologically beneficial, but I also don't think it in this study it paints at least that early post-fire recovery as super detrimental. And I think again, some of those patterns might are yet to be seen which way it goes. But I think I expected, especially given those visuals, that it would look much more negative, that we would have seen less regeneration really consistently, or seen consistently really hotter temperatures because of that, just direct radiant heat all the time. And we didn't find that, so it wasn't it wasn't all out negative, but certainly things to consider.
All right, Nathan, thank you for the answer. Dylan put forward another question, wondering what time of year and under what tree species when finding those morels. The important question.
Yes, the critical question. So those morels are all in kind of mixed conifer mid-elevation forests, and they I've found that like early to mid-June is perfect. Like June 15th is a prime time. And this was, when we found these, it was actually kind of funny. We were like in a stand that had a whole bunch of like stumps of Gamble oak. And I thought that that's what we were about to sit down all around when we sat down to have lunch. And then I realized that we were sitting amongst like this field of morels. You can see them in the picture, like they were the highest density per acre I've ever seen. So it's abundant. Yes, and they do respond to fire. That's actually one of the best places to find them in the Western US, is an area that's burned in just the last couple of years. The density has started to taper off now that this fire is 4 years old.
Nice to come across that windfall.
Yeah.
You had mentioned something about, these are the short-term impacts, right? This is the first 2 years. And you also mentioned that you were working with private landowners on this study to possibly enable looking into the long-term impacts in the next, 5-10 years. Do you have plans to follow up on that in the future?
Yeah, absolutely. I have a student that's currently working on these similar sites, as well as plans to continue to monitor these long term. Again, it's my excuse to be down in Southern Colorado, one of my favorite places in the state. So I definitely plan to be back many times.
Okay. John asked, do you think that if you left a few more 10 to 100 hour woody fuels or logs, so something like contour felling, on the ground, that would increase or decrease the temperature and moisture?
Yeah, I think it could, as certainly, as Rachel mentioned, those like microsite conditions, I think could really impact the decrease the temperature, increase the moisture. if you left more out there on the landscape, because it's pretty stark moonscape right now, or when we did this study. So there really wasn't very much many fuels out there. But we also did not like place them, strategically. We tried to be very randomized about where they ended up on a particular plot.
All right, thank you. Ruby asked if you're looking at any of the regeneration effects in the areas of moderate severity.
Yeah, so in this study, we kind of grouped low to moderate. I kind of ran through it quickly, but our low category was definitely up to 50% tree mortality. So it wasn't like, it would have been in some of those areas on the map that were yellow, where, we assessed it by tree mortality. We didn't differentiate low to moderate, so that could be an interesting angle. I think the difficult part about that in terms of the study design is finding another site that could be paired with it, and adding a whole nother set of plots that were that severity. So we didn't address that perfectly well, but I think you could probably assume that they were pretty similar to the low, because we did ensure that all of the sites had experienced fire across the whole plot. And so in some cases, especially in those like mixed conifer area sites that had more fire intolerant species, it was really pretty high mortality.
Yeah, I think I saw in the paper you mentioned that low to moderate severity was like a 53% mortality rate versus the 99.8% mortality rate.
Yeah, exactly.
All right, Nikki was wondering, why were landowners interested in clear cutting and removing most of the debris instead of leaving more trees or logs?
Yeah, I mean, I think that at least the ones that I talked to before they did it, the driving force seemed to be that the sadness about this drastic and immediate change on their forests, and they wanted to not look at the black trees where it used to have a forest. And I think that the contract that they wrote up with the timber company to remove those trees was to take all of the residual fuels, because they didn't want to contribute to another fire. And having just experienced that event, they were really cautious about contributing to an increased potential in fire behavior.
All right. Susan asked, if I was a landowner with forest land burned at mixed severity, what would be your top 2 to 3 recommended actions I should take?
Ooh, okay. Well, Susan, it kind of depends on what forest type. So if you want to let me know that might change my answer. But in many cases, if it's a mixed severity fire, in a lot of ways, you probably don't need to do much if you have some tree survival. You could remove some of those dead trees if you're worried about fire danger, but in all likelihood, if it burned at mixed severity and you have tree survival, you are probably better off in terms of your fire hazard and fire danger into the future than you were before that fire. And so I would think you probably don't need to do a ton of things as long as you're happy with the number of trees that survived.
I think that folks like John Galvan and Susan, I'm sure you heard about the Herman's Peak Cap Canyon fire that burned here in early summer. And so I imagine that they might be thinking about, mixed con, like ponderous pine up into mixed conifer, which is sort of what that landscape was. So these questions are probably coming from that angle, as well as thinking about the contour felling for erosion control. I think it's probably where most of these questions are coming from.
Yeah, definitely. I mean, I think that's, we didn't look at those immediate post-fire actions like erosion prevention. I think contour felling and mulching has been, especially wood mulch, has been shown to be somewhat effective. The difficult part there is you don't know, unless you're doing all the landscape, which is an impossibility. You don't know exactly where those flooding events are going to be or those big rainfall events. So it's difficult to put them for sure in the right place. And I think, one of the things to remember is that a lot of our landscapes, including in the Calf Canyon and Hermit's Peak Fire, is that many of these forests were less forested, say 100, 120 years ago than they have been because of fire suppression. And so reducing that density or small gaps, small openings in the forest is not ecologically detrimental or bad for the ecosystem in any way. I think the things that we really want to watch out for are those really large high severity patches, both from a erosion potential as well as like a recovery potential, if that helps at all.
Yeah, thank you. And I think you mentioned that someone else on the call is following up on this type of question. Exactly. So we'll keep an eye out for more research in the future.
Yeah.
So I know it's late for you and we are coming up at the top of the hour. So I want to thank everyone for being on today. Camille, thank you so much for taking the time to give this presentation and answer all of these questions. It's been great to see your research. I did drop that link to the paper in the chat if anyone is interested in going back and reading through it. And I also put your contact information for anyone who wants to follow up with you specifically. So
yeah, absolutely. And we are looking, really concerned and wanting to help with that monitoring and recovery of the Calf Canyon and Hermit's Peak Fire. So if you have a desire to reach out on those topics, I'm happy to talk as well.
All right. Well, thank you so much. I hope you have a great rest of your evening and hope to work with you again soon in the future.
Yeah, great. Thank you, everyone.
All right. Thanks.